How's it going? Brandon will be joining us here shortly to kind of answer questions and make sure that I can see everything that's going on. Um, let's just let everybody file in. I know it's kind of been live for like 10 minutes while I figure out. It's been a minute since we've done a live stream out here, so there's a couple things I had to figure out. Let me know how the sound is. Um, and then we can go from there. Let me just get everything pulled up here. So as you can see tonight, we are going over the XU of the for the Talos. This is a this is how the Talos will be set up. Granted, we have all the covers off, and the other main difference is we put on the Chimera full-size Chimeras rather than the XSs that would come on it or the LGXs. LGXs are in these boxes because they're like the perfect standoff. And I can't fit the testing setup on this bench. So moving forward, we're gonna have to move this bench off, bring in the whole testing unit, so you guys can see kind of how we tested over everything. But as of right now, I'm gonna set it here. The big thing is like it may walk around a little bit because it's just sitting on boxes right now, but it's not going to. It shouldn't walk off the table. We are moving at about 1,000 millimeters a second. We should have. Let me make sure that that is pulled up. It's got to refresh. Connecting. Here we go. And this is just a. We should have. Let's see. Just double check this one real quick. Okay, we're gonna be able to see our speeds and stuff like that, right? We do have a new camera compared to what we used to have, which kept flickering on and off. You can thank Joe Spanier for that one. He sold me a very nice camera. A good replacement for this one that we had for the overhead, which we're going to be swapping out our overhead camera for our 4K cam. It's just not set up yet. Found out that one of my HDMI cables was borked, to say the least. That's what it did. I unplugged it and it's like, nah, no. It's like, okay. And it was the one that was plugged into the camera that worked every time. So tell me how that happened. The one that was for the overhead that kept flickering?
Yeah.
Can you hear my air conditioner? It doesn't look like it. When I talk, though, you don't hear that in the background.
No.
All
No, you sound better on stream than at this part.
Good.
It's good.
All nice and sensual. We need to do an ASMR 3D printing stream. God no. God no. That makes my teeth grind just thinking about it. Do you remember, Brandon, you've kind of been in 3D printing for a minute, but back in the day, companies would they'd make songs out of their 3D printers.
Yeah.
Old Lols did it. Aleph Objects did it. And I thought it was hilarious because back then, like, everybody was pushing for a quieter and quieter printer. Like today, you have your Bamboos and your K1s and stuff like that. And because they're pushing for speed, and the Vorons, they're pushing for speed, they aren't quiet. Like the Daedalus, not a quiet machine. Because we were pushing for reliability and speed. But back in the day, like 3D printing back in the day, so you're looking at like a whole 8-10 years ago, you used to see a lot of people taking, the Imperial March, and you used to see a lot of funny music made by just moving around the printer. It's just kind of funny how things have changed over time, you know. For some reason, I can't get Twitch to pull up on any. Yeah, it's not pull. I'm not signed.
We don't have a ton of viewers right now.
I can't see them.
One of my things that I used to do, I created a whole bunch of tones for drones.
Tones
so I
for.
learned about this at the same time as 3D printing.
Oh, okay.
And so on the motors, on the startup one for the motors, I created all these songs. I had a whole
Okay.
I had a whole directory of different songs at one point. I don't know if I ever told anyone else that.
What a
Like
nerd.
all these different songs. You know, it reminded me of the days when you get the old Nokia phone.
Yeah.
And you could create your own. I don't want to call them 8-bit noises, but essentially 8-bit noises. You know what I mean?
Yeah.
Where you could have these little bit noises and make tones. And I went back to that and created all these songs from the cell phones back in the day, and then recreated them for the drone noises. You plug them in on the startup,
Yeah.
and I had all sorts of music going. It was pretty fun.
Brandon,
I did it with the.
I'm sorry to let you know, but you're a nerd.
I know it's sad.
Yeah, I mean, eight 8-bit, boring. So one thing we're gonna do is we're going to this system we were testing centralist homing on. It's probably not going to be something we're going to do in the future. Only because it doesn't really make sense. That's really slow. What's that? So, oh, let's just do this. We're going to send it a code real quick. 564H0. That's real slow like, right? Nobody wants a slow print. That's just dumb. So that's rocking. All right. So let's see. Let's go over some stuff to start with here. Okay, yeah, we're on the right. All right. So this is, like I said, this is our XU, pretty much the tester, right? So I'm gonna unplug these. Everybody's gonna tell you never to do that. Oh yeah, I can do that. I'll break things and I'll fix them. All right. So we have these two plates on the sides here. Nothing's painted on this unit because this was our tester. So we have two. Let's start with the rails. We have MGN12s with the H series, so the longer carriages on, and we have two of them on for each head. So these heads are super rigid. They're also the sheet metal that it's made out of is 3mm steel, cold rolled steel, and bent. So if you've ever worked with sheet metal in the past, bending it adds a lot of rigidity to sheet metal. But the fact that it's 3mm plate, it's pretty chonky stuff to begin with. So this whole plate system comes all the way back, and then you'll have a finger that comes down here and here behind the tool boards, and that's where our belts are clamped into. So that whole piece it's one full piece. So you're never gonna have like that get loose, and then we didn't want it to be a secondary piece, mainly because if it did ever become loose, troubleshooting for an end user is like digging into this part way back here with your cable chains and your belts. It's just going to be a pain. So we wanted to make it as robust as we could, and making it out of one full piece means that we're not going to have any bolts or anything like that that would come loose over with vibrations and stuff like that. As you can see, we do have tool boards at the top. So these are Duet 3. This whole system is Duet 3 base. We will have, in every machine, you have 4 boards, actually 5, 4 subcategories though. You're going to have your main board, which is a Duet 3 6HC. You're going to have a breakout board because we have so many stepper motors in this machine. We have 4 Z's, we have 2 Y's, and we have an XU, and then 2 extruders. So the main board is going to mainly be running your Z, your X and, or sorry, your Y and will also be on the main board, and your X and U will be on a sub board, which is a three, it's just a daughter board. It's got 3 additional drivers on it. It's all ran over CAN bus. That's going to be one major factor in this printer. Sorry, my head does get cut off in this video because it's a wider video than it is a tall video, but I want you guys to see this more than my stupid face. So you're going to have that in your electronics box, along with, up to 3 SSRs, 2 power supplies, all that fun jazz. Then it's going to come out in CAN wires. These will run all the way back to the main boards. But then you're going to have a CAN wire and a power. So for CAN, you need 2 twisted pair and a power. So everything on the system, except for until you get to these tool boards, is going to be 48 volt or mains. These will be run with 24 volt along with this daughter board in the back. So we'll move these in. So from here, we work our way down our cable chains. These are IGUS cable chains. These are not the wires that are going to be coming with this. This is just silicone 16 gauge wire. Everything will be, there'll only be a single wire in this cable chain. It's really a cable, not a wire, because it has a pair, a twisted pair and a power pair together. Hey Mitch, how's it going? So let's make sure we have, oh, hi, you made it. I was able to make it into the Pez live stream. Yeah, was that yesterday? It was Friday. Man, it's been a crazy week. So I appreciate you all stopping in. So yeah, so as we work down, we also have a tool distribution board. So what we're gonna have is here's another cable chain mount. And out of that, you're going to have your 2 stepper motor wires that'll go out to these 48 mil stepper motors. And then you'll have one cable that has your twisted pair for your CAN and your 2 power wires. Those 2 power wires will go into this here screw terminal. And then there is an Ethernet jack. It's an RJ11 jack that you'll plug into here for your CAN. And all of this is how this is going to come, plus covers and it's going to be painted. But when you would install this subunit, the subassembly, all you do is you clip in your cable chain and you plug the RJ11 and the power ports, and then your 2 stepper motors will have a quick disconnect. And then it's all wired up. Nobody's got to wire anything. That's kind of what we do in house. So that works us down to here. This plate back here is just for your cable chain mounting, your splitter here, and then let's just make sure it doesn't fall off again. So then we work out. We have 2 plates. These are not identical. If you see, as you can see, one stepper motor is higher than the other. That's so that we can run 2 belts across the back that are in the same plane, right? So that we're not staggering anything too crazy. We're not having it way up high or down below or anything like that. It's all in the back. So we're trying to keep this as low profile as possible. When we were working on this printer, we saw a lot of printers on the market in this size range. Granted, a lot is like 4. But they would stack sheet metal on sheet metal on sheet metal, and they do a single bend on it, and they just do this crazy tall system. And their cable chains are moving around way up here. And all it's doing is cantilevering all your weight back and forth. We're trying to keep it as slim as possible, as light as possible. Granted, we are using steel, but we want to be able to achieve speeds that nobody else is achieving. So that's the big reason why we're you're going to see a lot of weird stuff. So these side plates are actually like an L shape. So we see here. This is the mounting face for our Y linear rails, which are MGN 15s, the long carriage. And then you'll just have your stepper motor, and then that's really all that gets mounted to this plate. But it is rigidly mounted, 2 on the bottom and 3 on the backs of each side. So these things are robust plates and mounted in multiple locations onto this 2040. And of course, you change your belt tension by moving your stepper motors out. We have a little contraption that slides in that presses these out. And those will be standard with the printers. But yeah, the only thing that's not really metal is the cable chain like carriers in the back. They are not final, like they are finalized, but we haven't decided how many we need. So we're also thinking about changing one thing before shipping, which these units start shipping October 30th for the 600s. But we're gonna have a mid plate that's mounted, so because the cable chain's not moving around that much, really. We'll move those back out. So yeah, like I said, we're running for our test system. We were running it with the full-size Chimeras, which really, if you go on their site, they're not even making the full-size Chimeras anymore. But we wanted the additional weight. We're going to be running XSs and LGXs with Aces and stuff like that. So it's going to be a lot lighter. But we wanted the capability of making sure that, so we wanted to be sure that we can move at the speeds that we wanted to move at, even with more weight than we intend. So we did weight them down quite a bit and just started running them. So it's kind of like the rundown of the system. This is going to be a shorter stream. Going to shoot for probably about an hour, just because this is a holiday weekend for everybody in the U.S. Sadly, I don't think Canada celebrates anything this weekend. But it's almost Thanksgiving up there, isn't it? Isn't it like, well, their Thanksgiving? I don't know what they call it. But yeah, so hopefully no, Boxing Day isn't Boxing Day their Black Friday? Where they just go out in the street and box everybody? Yeah, that's how that works. That's why the Canadians are so tough. That's why they're really good at hockey and fights. Oh, I love hockey. I haven't seen much hockey lately. So, we are going to... I'll shut this Twitch off because it is pointless because it's not logging in. So, we're going to go over here. So what we did, well, right now, one thing is these X and U motors will be running 48 volts because the Duet 3 is the Duet 3 6HCs are capable of 48 volts along with the daughter board. The only thing that's not is the tool boards, which is fine. Let's be honest, you're not really able to get 48 volt heaters from Slice or E3D, so it's really hard. What you would have to do, if you're not running tool boards and you did want to run a 48 volt system on the main board but still use your heaters, your standard heaters, your standard fans and stuff like that, what you do, because Duet turns everything on and off with the negative pole. Thanksgiving is Monday the 9th. Oh, yeah, so you're not too far off. I just, you guys don't have anything going on this weekend, do you? I didn't think so. All I knew is that you guys had the earlier Thanksgiving, which makes sense. Let's spread out the holidays a little bit. Instead of stacking them all. They have a Remembrance Day?
Yeah.
I guess I just haven't really spent... I mean, I haven't dealt with holidays much in Canada, just visiting Canada. So, anyways. So, yeah, if you wanted to do a 48 volt system, if you have a Duet out there, but you don't have the capabilities of getting a 48 volt heater or a 48 volt fan or anything like that, and you don't want to pay for custom stuff, what you do is you run your power wire, your positive wire, back to a 24 volt power supply, and you run the negative back to the board, and you're able to switch it on and off that way, but still only get 24 volts of power to the system, or to the component, right? So that is a way to do it. But we're going to be running, because this machine is so large, we're able to put a second power supply in it. We're going to have a 350 watt 48 volt power supply and a 350 watt 24 volt power supply. That 24 volts is literally going to run these two boards. This accelerometer is already built into the boards, so we don't really have to worry about that. But there is the external accelerometer. But things like that's really all you're going to have to worry about with 24 volts. And we're giving it 350 watts because we've already had a couple customers say, hey, I want an ACE extruder set up with the LGX running a Mosquito Magnum Plus. We don't have the Mosquito Magnum Plus on the website. Why? Because the Mosquito Magnum Plus is so difficult for most end users to deal with. We sold a handful to a very large company with some very smart engineers at this company. And the first thing they did was, we told them, large nozzles, higher temp materials. And they put Joel Telling's High 5 Blue HTPLA in it. And they destroyed about $900 in hot ends, because it vaporized the PLA and all it left was black soot that we couldn't get out. We had them send them back to us and we couldn't get them out. So we ended up switching them down to mosquitoes. But for those that are printing large things that they won the Magnum Plus and they have experience and you're able to prove that you have experience with it and you understand the fact that, hey, this is not a PLA hot end. We are doing the ACEs. And those systems take 2 heater cartridges that are 50 watts apiece. These have 6 amp output on the heater, but it only has 1 heater port, so you do have to daisy it, which sucks to me. But I wish we had to. For how giant these tool boards are, shoot, they should have a helipad on them. If you compare them to like a CAN bus board for like a Big Tree Tech or something like that, those things are tiny. These things are huge, but they were built around the to actually mount. So this mounting pattern actually works on the front of this Humera. But we don't want to put the boards out there. We want to keep them up and away. We want to be able to put a cover over this. And if somebody, like, we do have higher temp stuff. We have heated chamber units coming for the Talos. It's in the works right now. But we want, when that becomes a thing, to be able to put fans on these. You can't really do that if it's hanging off the front. But yeah, so that is kind of like why we're doing that up there. They're 24 volts. It's the only really 24 volt thing, blah, 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 blah. So yeah, but right now we have our kind of our tester unit that we have a handful of these. We slap them on random things and we move code around just to have testers that are really kind of throwaway. If I drop this and break it, if somebody spills something on it, it's not a 6HC, it's not $300 worth of electronics, it's $100 worth of electronics, and really it does a lot of what we need. So, but what's crazy is even at 24 volts, we're hitting the speeds that we want to hit with this thing. And it's like, and we still have, we're going to have a lot of headroom. Because these are 48 mil thick steppers. And when you're working with something like a Core XY, you have, if you're moving in X or Y, like independently, you're really working off 2 stepper motors. There's a lot of belt. But really what we have is, for any one motion, you need 2 steppers. Here we're really getting everything out of 1 stepper per head. But yeah, we're able to really boogie it around. So if we look here, let me double check and make sure that I'm on the right thing. Open that up. So if we go to overhead, make sure that works. All right. So if we look over here, Let me pull this up. And you can drink some go-go juice. All right. So if we just move it around by, oh, hey guys, always plug your stepper motors in. Don't be mean. Also, turn off your power to your stepper motors if you want your drivers to not fry. Or if you want to live dangerously, don't. That's the world we live in. All right. So if we're moving just single heads, right? It's telling it to, it's not even, there it goes. It's saying 100. Is it even clicking? It's not even showing up on there, is it, Brandon? Do you, you're seeing the speed. I'm trying to see if my mouse comes up. Okay. All right. Apparently I have to be on it. Let's see if it shows up this time. 1 second. I just got to double check, make sure it's showing you. All right. So now we're seeing it. Apparently it doesn't show actual screen while I'm not on it. So anyways, yeah, we got, it's just telling it to go at 100 millimeters a second, and it's the requested speed, and that's what it's saying it's topping out at. But nobody wants to see, like, that's boring. Nobody cares. We're gonna bottom this out real quick. All right. So now, okay, so we're gonna send it a rapid move command on U negative 500 F. So we're gonna go 30,000. What did that show up as? How are you gonna see it? What's that? All right, 500. We can do better, right? So we're gonna send this to 0. It's gonna crash. We're gonna do it a little bit slower. We're gonna do it at 3,000, which is very slow. Oh, wait, no, let's do this at, I'm gonna move it at 600 and maybe loud for a second. Like I said, we were doing centerless on it. I shut centerless off. We're actually gonna have full end stops mounted. All right. You wanna stop? It'll at least say it's where it's supposed to be though. Okay, now when I send it to go somewhere proper, let's just make sure we got our normal breath, like our normal motion here. Once you guys see the speeds up there, we'll actually start moving it. I'll switch the camera view up. Okay, it's a little low. Let's go 500. Ooh, not 5,000. And then we'll switch this to 100. What we're going to do is we're going to move back and forth about 400 mil here. Nope. And then, so we did 30. That's this. And hey, I mean, it should pop up. It should have said, what was that speed, Brandon? Did you see it? About 500. All right. But we're going to go up from there. So let's go 6,000 and move it to 500. Boogie in. Boogie, boogie, boogie. Let's see what we get. So you're going to see your requested speed and you're going to see your top speed. Okay. All right. Right now, this has got the lower speed. So what we're going to do is we're going to adjust. Oh, it's because I have it maxed out. Got to bring this up to 80. What's that?
That is pretty cool.
Yeah, yeah. I had it set at to max out it. So wrong. That's for millimeters, right? Max instantaneous. Okay. Let's save this real quick. Run config file. Okay, let's go back to live. And then, because this screen is going to reset. Okay. It's going to reconnect. All right. M18. M18 doesn't do what? Is it shuts off your stepper motors. Actually, let's move this way over here. And then we're gonna send M564H0. Don't send M564H0 and duet unless you are being very cautious, because if you do that, what it does is it shuts off your end stops, and you will crash everything. And you can just move everything. You can move Z to negative 5,000, and you're gonna have a nozzle buried in your bed. You don't want that. Not at all. Okay, so now, that's been sent. So we're gonna send this over. Okay. So now, what is that? All right. Now let's send you to that is not correct there. That did that. That so that requested a speed of 1,000, and it went 1,000. A little strange that it went over. So let's see why. We have our steps per millimeter set at 160. 1 second. Let me do a calculation real quick. So this is a different electronics than we've been using. So calculator. So I just got to change my Z or my steps per millimeter to the proper one. These are all 0.9. That's 1, 2. And we're doing a 22 pulley. $160. Well, that's right. Yeah, that's right. Okay. The 700 millimeter lead screw. Okay. So now let's go to 500 at that speed. Let's get this old back up. So big thing is we're able to move over. We're sitting at about 1,000 right now. So let me bring it back up to this so you guys can kind of see what we're looking at here. When we send this. So we're moving 400 mil. And we're able to do it at the full 1,000 right now. Right, so I have it set at 80,000 is our max. So let's see what we can get done here. 1. And so I think so this is where we have it kind of frozen in firmware. Oh, that's sitting at, nope. I can go faster than that. I know you can. Let's move this back to 1. So it's calling 133. So what we need to do is just the accelerations are fine. So let's do this. Boop, 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 boop. The nice thing about Duet is you can adjust on the fly. I believe you can do that with like all your clippers and stuff now. So what we're going to try to do is we're going to try to hit our full max. Nope, that's not what I wanted. So I'm just changing that there. And now we're going to go back to our console. And we're going to see what our max is here. I didn't see what we hit. Let's go back to 1. So that's right now we're sitting at 1200 for rapids. Right now what we're wanting to do is kind of bottleneck it down to where on units that are shipped, we want it to go at about 1,000 rapids. We want to be able to know we hit higher, but at the same time, we don't want everybody running at bleeding edge because things just become more inconsistent on bleeding edge, right? So we don't want that really. But what we're going to do is we're going to see where we can go. Let's go 100,000. Right? How many zeros are in 100,000? It's a yoke. I got it. I promise. Okay. The goal, I mean, what would be nice is if we can hit about 1,500 actual movement speed without it skipping. I mean, we have the space, but we're also making sure that we're actually hitting those speeds across that space. So let's go 90 before we hit the full. Oh, we got to change this to. So right now this is going to be moving at about 90,000 millimeters a minute. There we go. Yeah, that's the right term. We just gotta watch those numbers and make sure. See, we're still hitting at about 1,200. What's it calling for? We went about 1,200 millimeters a second. It's calling for 1,500. Let's make some changes. I think what we're going to have to change is our accel. Let's change our accelerations up to, right now we're sitting at only 2,000. Let's go up to 5. So if you, one thing is we talked to Duet directly about acceleration speeds and stuff like that, and why we are seeing everybody in the world's talking about how they're getting they're doing 10,000 accel and all this other stuff, which is great and all, but we were seeing, if we were running like a Duet or a Daedalus at 10,000 acceleration with the same motors, we were getting skipping. So we reached out to Duet and we're like, why? And they're like, well, the way Duet calculates accel is different than the way Clipper does. So our lower acceleration numbers, we're still getting the same. Just because the curve is calculated differently from our understanding. So we're gonna go here. We're gonna see what we can get going here. Boop boop. Ooh, she was quick. Ooh, that's a little too fast. I didn't even see what that was. Oh, I missed it. Brandon, did you see what that was?
Nope.
Yeah. Yeah.
I was looking up fast.
Well, what's his 24/7? The guy, I think he's up in Canada too.
Didn't he claim like 90,000 or something?
I don't know. He did a video not too long ago. I'm not gonna hate on him. I mean, he did a lot of cool. He modified a zero to do some crazy things. But you can always make something go fast but not be usable. And he did a video recently where he made a functional part, but I mean, granted, with those speeds, he was still seeing the part kind of looked like poo poo. I think is the best term for it. Let's see, that's negative. I meant to go positive. That's 100. All right. Nope. Thinks it's at 550. Let's do this again. Again. Boop. This is not normally how we do testing because, you know, we okay. So let's do this. So this is more of just to show you guys some fun stuff. So the last thing we did was 90 thou, but we did it at 90,000, not thou. At 90,000 millimeters per minute, and we had it set at 5,000 Excel. And then we had some skipping. So let's bounce this down to 4,000 Excel. Let's see what speed we can get out of that. It's scooching. I mean, top speed is still 1264. I mean, that's fast. Oh, it's not 1500. We're gonna go 100,000. Boop. 1264 is still our max. So we found our kind of our limit there at least on 24 volts. We're skipping at 100,000 millimeters per minute requested. But it's maxing out at 1264 millimeters per minute or per second is our top speeds from a requested lot more. So what would that have been? What would that be? Let's go back to, let's do 300. So it's requesting 1667, and we're only hitting 1264. We should go faster somehow. But so, well, big thing is we'll get a 24 volt power supply on this. Oh, we'll just move the whole system over next time. 48, because this board won't take 48 volts. Oh, I can show you what it does take 48 volts. What? Hey, I've got a demonstration model here. So we ordered a bunch of 24 volt power supplies. And they sent us one not 24 volt power supply. It was 48 volts. Let's switch over. Just want to make sure you guys can see this. So when you put 48 volts onto a Duet 3, right, you get, come on, you see right around there. Come on. And it burns all the way through to the back. And that's what happens when you put 48 volts and a 24 volt system. Before we go, I do want to show you some other things that have happened in the recent months. We had a Daedalus unit get sent to a customer, And they said, hey, this unit's not square. And we're like, hey, we build it on a granite surface. We know it's square. And then they send us a picture and we're like, that's not square. UPS decided to have their way with our machine. This is 2040 extrusion, right? Pretty good stuff. This is our flat face. This is our, the most expensive piece of extrusion in the entire system because we get the flat face. But if we look right there, see how bowed out that is? Same way on the other side. So this is a 20 millimeter M5 bolt, all right, that goes into the frame to make sure that your frame is sturdy. Surprisingly, the threads were fine. We didn't use them again, of course, but this actually bowed out the extrusion. And when we got it back, the whole system tilted back and forth because of how loose it was from that. But hey, if even with 2 inches of foam all the way around the system, UPS will always prove your packing expertise wrong. But yeah, that was the only time we've ever had a system do that. And it wasn't even that far of a thing. The box had 1 hole in it. That was it. It's a double layer box. It had 1 hole in it. So we're guessing they had to have dropped it on a corner or something. I'm not sure. Ooh, this is a fun chair. I always forget to do this sometimes. It's the little things in life. The little things. But, oh, I had a fun print I wanted to show you guys. Ta-da! So, the Arctos. If you have not heard about the Arctos robotic arm, it's awesome. This is a planetary gear, not planetary gear. This is a cycloidal gearbox. So you have that, and then you have your cycloidal discs for the inside. And they get bearings pressed into each one. This thing is, yeah, Brandon just posted the link in my bob. But yeah, check out this thing. This thing is awesome. They have a kit now from China. I believe it's like $300 if you want to get all of the hardware. But they say it's like, if you were to self-source it, you're looking at like $400 to $500 for the whole kit and caboodle. And they actually even have encoders for the stepper motor set up in that price. Of course, they're all like AliExpress type of stuff. It's going to take you a minute to get it unless you buy the whole kit. But, oh yeah, Mitch, this is something that I don't know if you have heard of this yet, but this seems like something that's like right up your alley. It's got a 600 mil reach. It's all printed and everything like that, but it's a good size for a backpack. It's a good size for throwing stuff at people from your backpack. Mm-hmm. Oh my gosh. Oof. Lose a step in one direction, it just comes around and smacks on the side of the head. 500, yeah. I mean, does that surprise me that you were looking at robotics arms last week? Absolutely not. Absolutely not. It's Mitch. Brandon, did you ask Mitch if he started on his? Or no, I think Mitch, you already have your new Zero built, right? But anyways, so this is a fun print. Looking at a bed sheet. I've looked into it. We had a handful of customers that use our printers and print farms. Look into like the best way to do it. And what I found is if we go off of like, one second. If we go off of something like this here, Rancor. Let me pull up the Rancor real quick so I can move the bed down because my screen's not working. 131. But Mitch, what I found was, gosh darn it, yeah, 5, 6, 4, 8, 0. We'll move the bed down. So what I found was, like, if you had a system and you had multiple units stacked type of thing, what you would have is something come around and have tabs on the front, have a custom flex sheet made that had tabs on the front that would just lift the front of it a little bit, and then have almost like a pizza picker upper come in, slide in underneath to break the tension, and then just kind of like raise it up so that you can lift it and then pull it out, and then have a second bed tray come in behind it instead of doing what's their names? It was like Voodoo Manufacturing out of New York had a robotic arm set up, and they went bankrupt. No, I don't think it's because of the robotic arm that they went bankrupt, and I believe their investors ended up stepping in to solve the issue. But yeah, I mean, coming in with a spatula just to lift the system up to pull out, and then have an insertion one. The problem is you have to have a way to indicate off the back, which I don't think the 0 does. At least my 0.1 over here does not. If you have a way to indicate off the back, then you'd want to come in at an angle, of course, so you don't get your magnets sticking too soon, and then to drop it, not like that, because that was terrible. But that's probably robotic arm is cool. And you could always find used robotic arms for like super cheap, but the electronics tend to be dead. And like without the electronics, it's kind of a dead system. There's a reason why they sell them for $1,000 for a $300,000 robotic arm. Spaniard's was always looking for a robotic arm. So whenever I'd find one, I'd send it to them. But the problem was that all the electronics were all shot. So without the electronics, you're kind of dead in the water. Because I'm sure if you'd have to fully redo all the control system, which I'm sure you could do. But anyways, but yeah, so like this was kind of our little. Does anybody have any questions about the XU? I know we only moved U, but we can move Y, or no, X. Not nearly as far, and not nearly as fast. So it does all move. I know I paid a lot of attention to the X, but not so much the U. But yeah, so yeah, if nobody has any questions or anything like that, what we plan on doing is Tuesday we'll be back with our normal streams. Tuesday we're gonna be doing another design stream. Thursday, the reason why we say that is because I made some changes to our Z. Just rounding off some sharp corners, stuff like that type of thing. Those plates are on their way here. Ooh. Go ahead, Brandon.
Would you be willing to show off your bolt rivets for the sheet metal?
That's what I was just looking at.
Oh, were you? I've been curious what they look like.
So, here, let me grab this. So, this doesn't have the stepper motors in it. Let me switch over my screen. So, I'm going to get closer to the camera again. Have a one-on-one, a heart-to-heart with you guys. So, the way you tension your bulb cam, the way you tension your Y motors, granted, none of this test stuff was painted. This will all be powder coated. This is powder coated red. This is powder coated red, but everything else is powder coated a gunmetal gray. So, boop, boop. Okay. So, this is one of our Y motor plates. like I said, 3 mil steel plate, right? What we did was we added this 90-degree corner. What you do is you'd have your motor with your belt. Your motor would be pulled by your belt. What you do is you tighten this bolt, which it would be a different bolt, but that was just kind of our stand-in. What it does is it applies pressure across this way. And once that's done, you come from the bottom, because if you've worked with NEMA 23s, you know that they're not threaded like a NEMA 17. You have a bolt going through it. And what we were going to do is we were going to have a 5mm plate on this side tapped. Problem with, like, we wanted to make sure that we can get we can beat everybody's pricing on this machine. So you have to find every way possible to lower your cost. And a 5mm plate added a little bit of cost. Also, the more you keep it on the same thing, they nest it a certain way, you get price reductions, right? So instead of doing taps, what they call these something? They're a press-in nut. So what you do is you'd have that there. You'd come in from the bottom when it's tensioned. You tighten these all up, and then you'd back this off just a little bit. So there'll be a nylock on this. Focus. Okay. There'll be a nylock system on this. This was just for testing, for verification. But let's take this off. We'll show you these nuts. So the big thing with these nuts is you need to be pulling through the metal. You can't like bolt. You don't want to pull from the top, mainly because like from the side that the nut is on, they are pressed in. So we have our plates here, right? Focus, you silly goose. All right. Get real nice and close on that. So these are a press-in nut. So what you always want to do is, because it's pressed down from this side, you don't want to pull up from this side, right? They're pressed. You don't want to apply a large amount of force to it to pull it out. So you never want to like go here and pull against, right? But pulling this way through, you're not going to have any issues. It's actually going to seat it, like it's going to keep it seated with active pressure. The big thing is when you're threading something and you're going with like thin plate like this, these are all laser cut. And the problem with laser cut is you're always going to kind of, oh, I can show you on this piece right here. You're always going to kind of have this piece right here, a start-stop line. Tell me if I'm wrong. Brandon's done laser work before. What is that, Brandon? There's 2 of them on this one. Okay, lead in, lead out. You would think, you know what I mean? Okay. That's probably what these are. These are probably tabs. So, yeah, that makes sense. So, you're gonna have those that will be cleaned up when we get them powder coated. So when you're doing a hole, they're not like tapping. If we were to have them tap them, they're expensive because they're smaller holes. So like these are M3s on this system, and they have those nuts on them too, pulled through the bottom. If we look. There's several of them. So 2 here, 2 here, 2 here, and 4 here. And that's all for our cable chains and our motor, or our electronics mounting. So, and up here we had to tap. But especially once you get above like a 3mm plate, you don't really want to go above like a 3mm. Hey, Chris. you don't really want to go above like a 3 mil bolt, like an M5 bolt, or you don't want to go like M5 because you need to make sure you're hitting enough threads throughout the system. So at 3 mil, an M5 is what? An M5 by 8? By 0.8? So 8, 16, 24. So you're only going to get 3 full thread of contact, right? With an M5. And to double check what the minimum contact is for an M5 bolt, Chris might know that. Minimum thread contact for M5. Minimum thread. So it, of course, it starts at M6. So yeah, there's standards for like minimum thread, and you're either above or getting really close with an M5 if you're just doing a 3 mil plate. So adding these nuts in, it makes a big difference. It helps because you're gonna meet your minimum thread count with this. It makes it thicker. So, but yeah, sorry, Chris. I don't know if you just joined in, Chris, but we are kind of wrapping up for the night, just because it is the holiday weekend. People are hustling and bustling, enjoying their time. I know you own a business, so there's no such thing as Labor Day. Kind of like for me, no such thing as Labor Day. So, I'm used to no holidays though. But yeah. So, if anybody has any questions, feel free to ask real quick. If not, you got it, yeah. We're probably gonna wrap up for tonight. Hopefully everybody enjoys it. If you play video games, hopefully you got Starfield and you've started playing it. If you dumb and like Brandon and I and bought the $100 stupid get it 4 days early thing, because we're idiots. We're suckers. We got suckered. Brandon's 6 hours in and all he's done is filled his pockets. Am I wrong, Brandon?
No,
that's exactly right. Yep. The loot, all the giblets. So, but yeah, if you guys, we're going to be back on Tuesday with the design stream on. Right now, it's called the Apollo 2. We got to come up with a better name than that. We'll be doing a lot of stuff with the Z. Though I got a hair. The goal is to have the X and U almost ready to send out to everybody who wants to make it if they want. And then we'll get a lot of stuff tested. But yeah, that's kind of the plans there. And then Thursday we'll be back with this whole table will get moved. The workbench. We'll bring over our test unit because we have a lot of new Z stuff with the tiny tweaks that we want to install and try out. So, but yeah, we'll be back Thursday. We'll see you all then. Sorry we're jumping off so quickly here, Chris. But thank you everybody that came. Feel free to follow us on here or on YouTube, whichever one you're on. If you're on Twitter or TikTok, not TikTok, gosh darn it, Twitch or YouTube, follow us on either one of those. But yeah, if you have any questions, feel free to ask or send us anything. Have a great YouTube, Chris. Y'all take care. Thanks to everybody who joined in. See you around, Mitch. If you guys haven't seen Liz's stuff, make sure you go check them out. And I don't know if anybody else is streaming right now. But yeah, keep doing awesome stuff. Enjoy the weekend. All right, guys and ladies and everybody, peoples, you all have a good one. We're going to peace out. Bye, Steven.